Good morning. Here's truly Professor Dr. Dolphy Gilpin here, and we are the quality in Soace in Quebec, Canada. Now we're just 7 minutes away from the Montreal to the airport, international airport. That's about a 7 minutes ride getting here. And we're on the amazing 5x12 matrix. And put you know the stem, steam, and stream application, and you may wish to consult with other visual showing to find out what these letters mean. But what we're doing there, we're focusing on the S in this video class. We're focusing on the S, and the S, as we know, stands for science. It also stands for space. Space is a separate field, separate subject of study. And in this occasion, we are focusing on space, science, space. As you know, we find space in NASA. Asterisk S, and the S stands for, this is National Aeronautic and Space Administration, space. Also space in SpaceX. Space in SpaceX. All right. Now, let's just put up this is our first principle, the nucleus representation of the 5x12 matrix, where these are the operators. UV double X H and YZ alpha beta gamma conical delta epsilon. These are not necessarily in order. Rho, I just write them down as they come to my head. I just do the K. And we have here delta, sigma, theta, omega, and another omega. And for one, lambda, zeta, I think that completes it. And this will be N. Let's put, line is there. the one separating this one then. So here we have it. I know the S is for space. Space. Now, you know, infinite output exercise of this thing, the conditional infinity output. In our earlier representation, we had the SLS representing serials like sign. This was just a way of saying or describing the magnanimous output. The magnanimous output, or the conditional infinity output, and we say serials like sand. Later on we came to know that SLS in space, as represented by NASA, mean the space launch system. I don't know, the internet sometimes doesn't have accurate knowledge, but I am able to find out that SLS also represents sodium, Laureyl, sulphate, which is a sort of a surf and cleaner. We have SS for the Space Shuttle. And SS for the Starship. All representing space here. Okay, we had already proved the conditional infinity output of this thing here, so and the serials like sign thing for the monetary output, and what we're talking about here is some financial and monetary support of the space program. So we have serials like sign. These are monetary serials. So we have monetary serials here, M, S, L, S. Where M equals monetary. And this was proven way back there from about 2014-13 in a 71 page or 71 pages of proof of infinity, or rather conditional, let's put bracket here, conditional infinity output in monetary serials. And this could be applied at the mint. However, the danger in this was if it's used in a very selfish way, then we could introduce what we call inflation and hyperinflation. In the economic system. However, if use prudent, I'll put here prudent use of it, not for selfish political purpose. I put here not selfish except for economic, political purposes. Then we could introduce prosperity to a system. Put here prosperity. Be it in space or in the normal economy. There will be no inflation or hyperinflation, but a balance, GNP and a balance spending and supply and demand. So what we have now, balance, right here, a balance, supply and demand. GNP cost / sales or balance. So we are on the space focus here, and we have SLS Serials lifestyle, and that has already been proven from the conditional output of the Amz5x12 matrix. And we have extended this to now the AM15 multiplied by 12 matrix, and the AM27 multiplied by 12M, and it could go on and on stochastically to AM 27 multiplied by 12 plus. But we have stopped at 27 by 12, but it could go on and on according to the needs of the society. So this is just recognizing that we said the S is in NASA area. And what this does also, it brings in a sort of a chemical orientation here. Let me put it in this bracket here. It introduces a chemical focus in which you could use all of these things to represent the periodic table, the NASA and the Spzce, or the PERIODI, the periodic table of elements. Very importantly, the periodic table of elements is introduced here. We have tried to spell NASA using, so like for N would have, just starting from the base of my head here, nitrogen, A would have like, just talking very randomly, aluminum, argon. For S, we'll have sulfur, A again, it's better just name the periodic table. Helium, well, let me just see, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, 9, 10 will be the second, neon, so N would be for neon and nitrogen, 11 would be sodium. But we have them, like for sodium, you would think it would start with an S, but it's really an N, A for the symbol of sodium. Anyway. So N would represent sodium here as well. We have a sodium, Laureyl, sulphate there. Sodium also take a recessive A. I was also giving you an example. I'm going by the periodic table here. So we have reached sodium, then 12 would be magnesium, 13 would be I believe aluminum, 14 would be like silicon, so S would be for silicon, Si, 15, 16 sulfur, 17 would be chlorine, 18 would be a next noble gas, which is the argon, I believe, helium and argon. 19 would be potassium, and 20 would be calcium. 21, 22, 23, and going up and so on. I've learned the first 20 from from high school time, and we have some random one like manganese, Mn, gold is another one we could put for AU, gold and silver already, AG, gold and silver for the A's, iron, Fe, lead, Pb, tin, Tn, titanium, Ti, and titanium is used very a lot in the space industry to make some of these structure for the space vehicles, titanium, and so on. So this is what the S focus brings in. It brings in a sort of a chemical focus as well, and is here where we're going to integrate the periodic table with 118 elements, and we'll use it accordingly as is relevant and necessary. Just to Professor Dolphy Gilpin here at the Quality Inn Hotel in 1010 Aron Street in Laureyl, Quebec, Canada.